So then my a squared is equal to 49. My u squared is 25x squared. That means a is 7 and u is equal to 5x. So du is equal to 5dx. And that gives me then that 1/5 du is the replacement for dx. So now when I come over here, I have the 4 that's out front, and this is times the integral of 1 over a squared plus u squared times 1/5 du goes in for the dx. Now remember, this 4 is over 1. So when I bring the 1/5 out, that's 4/5 times the integral of 1 over a squared plus u squared du. So that's 4/5 times my 1 over a arctan of u over a plus c. So that gives me 4/5 times 1 over, well, a is 7, arctan of u, 5x, over a, which is 7, and then plus c. And this inverse tan, you can write it as arc tan for arctan, or tan with the inverse trig function notation. So that gives me 4 over 35 times the inverse tan of 5x over 7, and then plus c. Next one. The next one, I have my integral of a polynomial divided by a polynomial, so it is a rational function. I don't have one term in the denominator. The degree of the numerator is smaller than the degree of the denominator, so I don't have to do the long division first. And the denominator is factorable. So if you look at this x cubed minus 6x squared plus 2x minus 12, I have 4 terms, and when you have 4 more terms, you try to factor by grouping. Out of the first 2 terms, we can factor out an x squared. Out of the last 2 terms, you can factor out a common factor of 2. And then between the 2 resulting terms, you have a common factor of x minus 6. So I can use partial fractions here by trying to write this integral so that it'll be my denominator of the x minus 6 for one of the fractions, and the denominator of the x squared plus 2 for the other fraction. Now x squared plus 2 does not factor any further over the reals. So when I go and I set up my fractions, a over x minus 6, because a highest degree 1 in the denominator, the degree less than that is degree 0. And then plus, remember when I attach the fractions setting up, I always put a plus in between. I don't try to finagle the signs. And my other denominator is x squared plus 2. Well, x squared plus 2's degree is 2. So degree less than that would be degree 1, but I might have a degree 1 term. I could also have a constant term. So the numerator here is going to be bx, so less degree than the denominator, but then plus c. And you just keep working your way down the alphabet for those numerators. Okay, now build and get a common denominator. My first fraction needs to be built top and bottom by the x squared plus 2. My second fraction needs to be built top and bottom by the x minus 6. And then when I remove parentheses, I get ax squared plus 2a plus bx squared minus 6bx plus cx, and then minus 6c. Now combine your like terms and factor out your common factors. So I have an x squared term in this first term. I don't have any x's in the 2a term. I have an x squared in the plus bx squared, and no other places where there's an x squared. So I'm going to put that terms that have the x squared involved in it together and factor out the x squared. So that'll be a plus b x squared. And then next, the ones with the x, and I have a minus 6bx and a plus cx. So you put the plus between, and in the parentheses put the minus 6b and the plus c with the x after it. And then the terms without an x would be plus 2a minus 6c. Now, when I equate these coefficients in front of the terms with the coefficients in front of the terms in the original numerator, a plus b has to be 7. Negative 6b plus c is the coefficient in front of the x down here, and that has to match the coefficient in front of the x in my original question. So negative 6b plus c has to equal negative 24. And my 2a minus 6c has to equal the constant. So this doesn't have an x in it, so it has to match the term that doesn't have the x in it. So my 2a minus 6c is equal to 6. So what you want to do next is to solve this system of 3 equations with 3 unknowns. And we can solve this again by substitution, by elimination by addition, by determinants, by Gauss-Jordan elimination. So if you go through and you work any of those, that a is equal to 3, b is equal to 4, and c is equal to 0. So working through those steps, those are the values you would get for your a, b, and c. Now look at how you set it up. A is the numerator for the x minus 6. So I take this 3 and I put that in the numerator for the x minus 6. B is what I had in front of the x in the bx plus c, and c is the constant term in that numerator. So this will be 4x plus 0, or just 4x. Now I can integrate these term by term. So I have the integral of 3 over x minus 6 dx plus the integral of 4x over x squared plus 2 dx. From this first one, you're going to get my u sub 1 substitution is x minus 6, and then du sub 1 will be the same as dx. So that'll be 3 times the integral of 1 over u sub 1 du sub 1 plus. In the second fraction, I don't have a monomial denominator. If I grab the entire denominator as the u, so if u sub 2 is equal to x squared plus 2, du sub 2 is going to be 2x dx. And so this 4, I can factor 2 to stay with the x, and then another factor of the 2 to come out front. That's 2 times the integral of 2x over x squared plus 2 dx. And then the 2x dx comes out for the d u sub 2, and the x squared plus 2 is the u sub 2. So that's 3 times the integral. So now when I'm looking at integrating, That's 3 times the natural log of the absolute value of u sub 1, and then plus 2 times the natural log of the absolute value of u sub 2 plus c. So that's 3 times the natural log of the absolute value of the x minus 6 plus 2 times the natural log of the absolute value of x squared plus 2, and then plus c. And then finally, this last x squared plus 2 is always positive. So I don't need to have absolute values around that one. My final result is 3 times the natural log of the absolute value of x minus 6 plus 2 times the natural log of the quantity x squared plus 2, and then plus c. Well, hopefully these examples have been helpful in how to figure out what to do when you're faced with integrating a rational function and different types of situations and what you would do in each of those situations. Thank you for watching my video, and click the like button if you found it to be helpful.